Assalamualaikum warahmatullahi taala wabarakatuh, and good morning to everyone. My name is Muhammad Fikri Adin bin Mat Daud. I am first year student from Industrial Technology School in Bioprocess Division. Okay, today I will talk a little bit about bioremediation, focusing on isolation and identification of new strain of microbe in crude oil degrading bacteria. This is to find a suitable microbe to use in degrading the crude oil pollution. Okay, first I will talk a little bit about bioremediation. What is bioremediation? Bioremediation is a process used to treat contaminated media, water, soil, and subsurface material. It's by altering environmental conditions to stimulate growth of microorganisms and degrade target pollution. Basically, there are two types of bioremediation, which are in situ and ex situ. This is when we do it at the place of the pollution, or we take the pollution and we do it at the other place. Okay, bioremediation is important because it can promote complete destruction of pollution, and it's very possible because by using bioremediation, instead of transfer the contaminant from the environment medium to another medium, like we transfer it from land to water or air, we can do it at the place, and it can complete the destruction of the pollution. Okay, next we will continue in the isolation and identification of the strand of the new strand. It is from a article given. Okay, we will continue in the micro isolation. The sample is taken at the Khan Island in Iran, which is one of the most important site for oil exploitation in Iran. Why we take it at this place? Because they have high possibility that there is a lot of crude oil pollution in the location. Okay, the experiment is carried out by taking 1 kg of contaminated oil, and after that you ground and sieve through in 2 mm pore size sieve. This is to improve the homogeneity of the sample, and it kept at 4 degrees C for less than 48 hours. After that, 10 gram of the contaminated soil is mixed with 200 ml mineral salt medium containing 200 gram liter of the crude oil, and incubate in the rotary shaker for 7 days at 37 degrees C and 150 rpm. After that, 100 micrometer of the sample is put in the solution of mineral salt of the 20 gram per liter of the crude oil. The inoculation was repeated for 3 times because to make sure the microorganism in the sample only bacteria or microorganism that can degrade crude oil as their carbon source. So any other bacteria will die in the process. Okay. After that, the pure colonies can be extract or can be take and can be grow in the beef extract, and it will be kept for further use to identify the bacteria. Okay, next we will continue for the identification technique. Before that, the DNA need to be extract first. The identification technique is carried out to assess the morphology, the characteristic, and the biochemical test is carried out to know the morphology of the and the other characteristic of the microbe that was be isolated before. Okay, first for the DNA extraction, thermolysis is used. Thermolysis is some kind of a boiling method, and at the end product we will get a pellet that full of the microbe or DNA of the microbe. Next, PCR method is used to identify the phenotype of the microbe. PCR stand for polymerase chain reaction, and this is a technique to make many copies of specific DNA region, and it's basically relies on thermocycling, which is the exposed to reaction to repeated cycle of heating and cooling. So it will be repeated cooling and heating. After that, the sample of the PCR was sequenced, and the data was analyzed by Chroma software aligned with the question program, and the result is is recorded in the experiment. That's all. Next, we will continue the characteristic of the microbe. There are a few characteristics that need to take into account when analyze the microbe or choosing the suitable microbe for the bioremediation. Some of the characteristic is the microbe need to be have the capability to grow in mineral salt broth containing 2% of the crude oil. This is mean that the microbe can degrade hydrocarbon or crude oil, so it's suitable to use for bioremediation for the crude oil. Basically, next we continue. Next, the characteristic is it can produce catabolic enzyme, which means it can produce enzyme that can degrade the biocarbon or the hydrocarbon. Next is having adaptation properties, which mean the microbe can adapt to another place. For example, it can coincidental induction of many catabolic pathway, which mean at different pollution it can adapt and clear the pollution. Next, it also can grow in extreme environment because at the pollution is at high level of petroleum with different combination, so it need to can grow at the extreme environment. So the microorganism can grow and can degrade all the pollution and clean the area. Next, it needs to has highest growth rate because we need to save time in the industry when we want to clean the pollution. Okay, next we will continue for other part. Okay, last but not least, we will continue with the performance of the selected microbe in this experiment or in these studies. There are nine samples that been taken, or 9 strain, and three strains show that they have a highest growth rate. Two of them is Pseudomonas sp from strain 8 and strain 5, and one Staphylococcus aureata from strain 3. Each Staphylococcus aureata have the ability to decontaminate the pollution, and all of these strain come from gamma subclass of the Proteobacteria and Firmicutes. Next, one of the bacteria, which is Acumobacter, have the ability to degrading PAHs, and the others bacteria have slow growth rate compared to these three strain, and these three strains show that they have the highest growth rate and suitable to be used for the bioremediation of the crude oil pollution. Okay. Okay, for the conclusion, I can say that there are three strain from the experiment that carry out that have the highest growth rate and have characteristic that needed to to become a suitable strain to use in bioremediation of the crude oil. And I suggest that to treat the crude oil bioremediation, dispersing agent or dispersant can also be used. The function of dispersant is to break up the oil into tiny droplets for easier for the bacteria to eat them, so it can increase the efficiency of the bioremediation. Dispersant also can stimulate the growth of the bacteria. Next is bioremediation have a lot of, we can use bioremediation in other than crude oil industry. For example, to managing the soil and slash sediment or contaminated oil, and also we can use it in sewage and compost bioremediation. So I think our country need to use and try to do the R&D in the bioremediation, because it is very useful and very useful for to the environment and to us. Okay, I think that's all from me. Thank you.